Hello, everybody, and thank you for joining us, Lighting Design Lab, to yet another webinar in our series, Lighting Retrofits and Audit, presented by Eric Strandberg. Next slide, please, Eric. Wanted to say just a few things, call out a few rules of engagement for our webinar today. Everyone is going to be muted for the duration of the webinar. Please engage with us using the chat feature at the bottom of the panel that comes with the GoToWebinar platform. Presenter is going to stop every so often. We're going to have a couple of polls, as well as we're going to stop for questions. If there's anything about the material you want to clarify or you just want to engage, please, again, use the chat feature for this. And when we have polls, please participate. The more engagement, the better the classes will go. After the webinar, there's going to be a 1-minute survey asking how we did and how you enjoyed the experience. Please fill it out. It lets us know, get them on how to go forward and always deliver the better service to our audience. Again, at the end of the presentation, we will be posting our recording of the class on our YouTube channel a couple of days after the webinar. And you can always reach out to lightingdesignlab@seattle.gov with any additional comments or questions. Next slide, please. I want to make sure everybody is aware, Lighting Design Lab is powered by and very much a part of Seattle City Light. Next slide, please, Eric. And we are the education and awareness hub for emerging technologies and lighting for Seattle City Light. Although we don't only work with Seattle City Light or the city of Seattle. It takes a village. We work with various other utilities, other energy efficiency organizations, strategic partners such as the University of Washington's Integrated Design Lab or NEEC's Smart Building Center. And we look to serve the full market spectrum on the lighting industry, as you see on the right-hand side. Next slide, please, Eric. Our 4 core service areas, the Lighting Design Lab, are education and training, such as these online webinars, in-person classes, other events, technology evaluation, where we do different pilots to highlight emerging technologies and best practices for the connected lighting industry. We help develop tools and resources like lighting guides, learning videos, so on and so forth. And last but not least, we serve as information aggregators, where we keep an ear to the ground on the latest and greatest happening in the lighting, utility, and energy industries, and are able to disseminate that information to our audience. Next slide, please, Eric.
All right. Armando, thanks. Are you turning it over to me now?
Yep, without further ado, Eric Strandberg.
All right, thanks. All right, Armando, and everybody, thanks for attending. Yeah, so this is going to be our class on retrofits, introduction to retrofits and audits, and we're going to do a little overview of Luminaire level lighting control basics at the end. I am Eric Strandberg. I've been one of the lighting specialists at the Lighting Design Lab since 1995. I'm like Father Time there. But I've been working in the industry for over 30 years, and I love lighting. And yeah, let's just move on to what we're going to talk about today. So we're going to do an overview of procedures and issues around doing lighting audits, some common retrofit options, and then we're going to look at the LLLC. I love this picture because it shows a crazy retrofit where, you know, there's all kinds of right ways to do things, and there's also some wrong ways, and this one sort of seems to incorporate both of those. I think it's kind of amusing. They took this fluorescent fixture and just sort of scabbed in a track fixture. So you just never know what you're going to find out there. All right, so this isn't really a quiz so much as getting a sense of who is in our audience and what their knowledge is and expectations. So Armando, I think it's a poll.
Yep. So, ladies and gentlemen, a poll has been launched. Please participate. Uh, Again, the more you engage, the better the class will go along. Polls calling out how many of you have done many audits and retrofits, do lighting, but want to know more about retrofitting existing buildings, are a contractor, but want to know more about lighting, are new to the field, or you're in the wrong class. All right, thank you for the responses. I see a good amount have voted. I'm gonna wait about 3 more seconds. All right, thank you very much, everybody. Let me share the poll results. We have a great majority that do lighting but want to know more about existing buildings. It's almost 50% there. Other big answer, hey, new to the field, want to learn many aspects of lighting. And also a good third of our audience have done many audits and retrofits, so assuming looking for a refresher.
Excellent. So let's move on here. So Armando, when I look at my screen, looks like my camera's frozen. Is that the case?
No.
Oh, there we go. I'm back.
There we go.
Yeah.
Very nice.
All right. Great. So thanks for that intel. Yeah, well, I think the nice thing about this class is there's going to be something for everybody. We're going to kind of cover the waterfront, if you will, on some basics, but there'll also be, hopefully, even for people who've been in the field for a while, there might be some little nuggets. So, one of the things that I find is often it's helpful to really figure out what the goals are for the project. I mean, you might seem simple. It's like, well, we want to save energy, um, and that may be the case. But if your client's ultimate goal is to save money, which makes complete sense from a business standpoint, nothing wrong with saving money, then that's going to send you down one path. It may be, though, that your client's goal is to save as much energy as possible. And that might lead you down a different set of decisions. So it's good to, it also may be that they have bad lighting and they have to fix it, or there's the system's degraded and they need to upgrade it. So there could be a whole range of things that are motivating your client. As an example, I had a water heater years ago that failed naturally on the weekend. And so I'm calling around some places to get a new water heater, and one company says, "Well, yeah, we can get you one on Tuesday." And I'm thinking, wow, that's not so great. And I'm about ready to call someone else, and he goes, "Well, I've got another one that I could get you, but it's the energy efficient one, and it costs a little bit more." And I'm like, "Okay, that's the one I want. That's the one I would have wanted anyway." For me, it was worth it to get something that saved a little energy, even if I spent a little more. And the salesman his assumption was that I just wanted the cheapest one I could find. And, so that would have been two opportunities lost. One, he would have, he could have, if I'd known that he had, there was a range of products available, I might have picked the more expensive one, which might have been good for him. And for me, I would have got one that was more energy efficient, which would have been what I wanted anyhow. So it doesn't hurt to explore some of these things with your client right up front and find out what their ultimate goal is. And related to that is a concept of what are the priorities for the different stakeholders and the different people. Especially if you're doing a large project, there's going to be all kinds of people involved. There'll be an owner, usually. They may be not that involved, but they might be, and they're usually looking at low long-term costs. Then you might have a tenant who's occupying the building or the floor, and they want to, maybe their goal is green status. They want to say that they're, a green business. The engineer who's working on the project, they maybe want to maximize the energy efficiency. The contractor is looking for a low bid, maybe low first cost. facility operator, they probably just want low maintenance. If they're, maybe it's a big institution, and so they have certain specifications or standards. It's like, okay, if you're going to be a tenant here, this is the kind of thing you need because it's good for us for low maintenance. And then the users of the space, they probably just want good lighting. And then the architect may be concerned about how things look. Hopefully everybody gets what they want, but it doesn't hurt to know that each of these different stakeholders may have different priorities. So doing a building survey, you're going to need to find out what's there and what the situation is. What is the percentage of lighting and energy being impacted? So, sometimes you have a customer where they just want to retrofit everything. We've seen this a lot lately where, especially big institutional clients, they're like, oh yeah, we want to convert everything to LED. And I worked with one customer not long ago where they had pretty much, sure, we could do, 95%, but there were some relatively new fixtures. In this case, they were bollards for their exterior entrance, and they really couldn't be retrofitted well. They were, they relatively new, and they had new modern metal halide lamps. And to retrofit those would probably just mean to replace them, which would be very expensive. And so we were like, you really want to do every fixture? So it doesn't hurt to kind of push on some of these a little bit. And often you get caught up on the hardest space. Maybe like in this case, we've got an auditorium where you've got, scaffolding to change the fixtures, but 90% of the building is relatively easy. So it doesn't hurt to push on some of the, maybe some of their goals a little bit. So is this building a good candidate for a retrofit? And so you want to find that out too. What's the opportunity? What's the probability of success? And you want it to be cost effective, regardless of what their priorities are. Usually, you don't want to spend more money than you have to, and so. One thing you want to look at is, does the facility have long hours of operation? We look at this old, server room, if you will, and it's probably very bright in there. It's overlit. It's old fixtures. So you want to look at some things like that, and there may be other factors. What are the utility rates? That's going to impact their payback horizon as well. And then it doesn't hurt to look around and see if there's any opportunities that don't involve the lighting directly. Like, is there a possibility for daylight? I mean, it wouldn't be in this case, but we see warehouses that have skylights that have been covered over just because maybe they leaked 30 years ago and someone just sealed them all up. But they could be brought back, and that might be an opportunity. Or there's controls. Maybe this space is vacant for certain periods of time, especially maybe at night, and there's just someone who comes in, and so they could have a control occupancy sensors. And sometimes the client doesn't actually know how much they're paying for lighting. They just see a bill, for at the end of the month, and they don't realize that maybe a high percentage of their bill is actually lighting loads. Clues for maybe when it's not cost effective. It may already be a fairly green facility. Is it a green building? Is it relatively new construction? If so, it's probably built to a fairly stringent energy code. It may have short hours of operation. They may be using a lot of energy when they're operating, but then they're just a sort of a 9 to 5. There may be other reasons why it's not eligible for a rebate that you might want to contact the utility and find out if utility rebates are a big factor in moving forward. or maybe it's undergone a retrofit recently. So these are things to look at. Here's a couple of spaces. Normally, if we were doing a live class, this would be a little bit of an opportunity for some engagement, but I'll sort of talk us through this. So which is more likely to be cost effective? So if we look in the upper right here, we have a big arena, you know, and they have hundreds of 1,000-watt metal halide fixtures. So you'd think that might be cost effective, more cost effective. Down here, we've also got a community center where they've maybe just got, you know, a dozen or so high wattage, you know, 400-watt metal halide. So you're thinking, well, that's not going to be as cost effective. But guess what? That big arena may only be operational, you know, few dozen times a year, especially if it's football. They're not playing that many games, and then maybe there's some special events. So it's dark most of the time. Whereas that community center, maybe they may have a 20-hour-a-day operation. They open early and they close late, and they have all kinds of groups coming in there. If we look at the lower one, we've got an office lobby, and then we have a hotel lobby, and maybe they both have the same power density, the same lighting loads, but guess what? That hotel lobby is 24/7. You know, it's open all day, all the time. Whereas the office, they may close. You know, they may be open at 7 in the morning at the earliest, and then they close by 7 in the evening. So, got to look at those hours of operation. All right, so you want to find out more detail, and it may be that you need to do an audit. Some simple spaces don't really require much. Maybe a warehouse you can kind of walk through and get a sense of what's there. But if it's a more complicated space or a big campus, you're going to need to do a detailed audit. And certainly getting your hands on the plans are one start. But you need to make sure they're as-built. And even as-built, we've found you have to go out and actually verify some key elements. So looking at similar spaces, like if you're doing a school, you probably don't need to go into every classroom because they're all pretty similar, except for maybe labs and some others. Then you would do the electrical circuiting, you might review that. And then you might check on recommended light levels and some lighting guidelines. For instance, if there's local codes or standards, and then what are the industry recommendations for these kinds of spaces in terms of light level. Some gear that you might want to bring would be, you know, I'm not a big fan of light meters, although I think they can be helpful. I don't live and die by light meters, but it doesn't hurt to have one, and you can get a sense of, you know, okay, this space is brighter than that space. You can't always tell with your eyes. So it doesn't hurt, or you could walk into an office and it's maybe, you know, 80 foot candles, which is kind of a high number, and maybe the industry recommendation is 40, so they're overlit. You want a measuring device. Measuring tape is good to have. A laser, they have all kinds of little laser measures. Those can be good, but be aware that if you're doing exterior during the day, that laser measure will probably be pretty ineffective. Or if you're in a very brightly lit, say, gymnasium or something, it may be not easy to use. And then different writing devices, tape recorders. Sometimes people walk around and they talk into there. They're not writing notes. A camera with a zoom and a wide angle, and we'll talk about that in a little bit. You want to have a real camera. It doesn't hurt, maybe even have binoculars or a little monocular so you can get a close look at things that are high up. And then, of course, the earplugs and hard hat is needed, safety vest and such. A counter isn't bad, a little counter. And then if utility rebates are important, it doesn't hurt to have those forms with you to help you out. So that's all this stuff. Then you want to document the lighting systems, and you want to, again, look at light levels existing. You want to look at the luminaire types. We'll go into this in detail. You want to look at how they're mounted. Sometimes you can have the same fixture with different mountings. Sometimes they're hung on chain, or they're mounted directly to the ceiling, but it's the same fixture. Could be treated the same way, perhaps. The lamp types, and the color and the wattage, and those are often difficult to figure out. The ballast types as needed, daylighting conditions. So again, walk around. One thing I do is always look at daylighting opportunities. You know, do they have windows and shades maybe that are always drawn, or do they, you know, and why would that be? Do they have skylight opportunities? And then look at the luminaires, and have they already been retrofitted? You know, if you've got a building that's 40 years old, which isn't, you know, that's the 80s. To me, that seems like a fairly new building. It may have been retrofitted once or even twice since then. So the as-built may not be quite as helpful as you think. And then look at the controls that are in use, and also look at room reflectances, and we'll talk about that as we go. Additional tips. So you look at what fixtures are there, but what condition are they in? Are they destroyed? Are they, you know, in dirty? They may be in good shape, but there's just a lot of dirt on them. So you just need a cleaning, or they may be, you know, shot. And so they may have controls, but the controls aren't working. You're walking into spaces where nobody's there, and the lights are on anyway. And then there are conditions, the ceiling type. What, you know, so is it a hard ceiling? Is it concrete? Is it wooden decking? Is it acoustical tiles? Those sorts of things. And if there's a plenum, what's the access to that? And then the reflectances we talked about. And then it doesn't also hurt when you're there to take a look in the maintenance closet and see what they have. That may tell you what lamps they're using, and maybe if they've had problems with some existing ballast or other electrical components. So it looks like we have a little pop quiz here. So Armando.
Coming right up. So we are launching a poll. Which of the following suggests that a retrofit is likely to be cost effective? And you can select more than one answer, so please select all that apply. Again, the more we engage here with the class, the better the experience we have, so please vote, don't be shy. Getting a couple of people voting already, it's good stuff. Oh, this is interesting. Very nice, thank you for voting in, people. Past the halfway point, get a few more seconds in there. All right, and I'm gonna close the polls. Let's share these. Well, got almost 90% of people selected that, hey, facility has long hours of operation. 73% believe the measured light levels are higher than recommended. 53% selected community theater stage has 50 plus 500-watt lights. Oh my God, of course. Hospital parking garage with 30-year-old lights, 60% voted for that, and a 33% selected the customer is going for LEED certifications. All right.
Yeah, well, thanks. So let's just break that down a little bit. So obviously, yeah, the long hours of operation is a good one. The measured light levels are higher. That we want. This is a little bit of a trick here. The community theater stage has 50 500-watt lights. It seems like it might be a fertile ground for a retrofit, but that stage is probably not getting a lot of use. You know, it's not a gymnasium, it's sort of a stage. And so it would only be on when they're doing a production of a show. And so that may not actually get a lot of use. We get this a lot with community theaters, where they have these high wattage lights, but they don't have a lot of burn hours. Hospital parking garage, so that's going to be on all the time, and those lights are 30 years old, so they're probably prime suspect. And then yes, the customer is going for LEED existing building certification. That's good for them, but it may not make it particularly cost effective. They're going for a high energy goal, but it may not necessarily be on the face of it cost effective. So that's good stuff. Thank you, Armando. So you want to document existing light levels. You know, it's good to see what's proposed, right? So sometimes the client, you know, they're like, oh, we need 100-foot candles, you know, maybe a retailer or something like that. And it's sort of like, well, okay, we'll explore that. That's a high number. Maybe that makes sense in some areas. And then you look at what recommended practices, and you find out maybe for retail, for this type of retail, let's say it's a big box, you know, they're recommending 60 at the, you know, at the merchandising. So you could, that would be a discussion you could have with your customer. They want 100, the 60 is recommended. Are the light levels consistent? You know, so you walk in, they say, yeah, it's too dark in here. And sure enough, right, it's pretty dark, but then you walk over other areas and it's actually pretty bright, vice versa. And then are the users happy with the light levels? So again, doesn't hurt to have your light meter, take some notes, and then of course compare them to some recommended practices. So here's the thing about phones, rather cameras. Everyone's like, yeah, when I go to a job site, I take pictures with my phone, and that's good. Doesn't hurt to do that. I do the same thing, but it doesn't hurt to have in your briefcase or somewhere a camera with a decent zoom. So if we look at this light here, we can see there's a label on there. So we're trying to figure out, well, what's the deal? What's the manufacturer? What's up with this light? We want to retrofit it. And so if I take my phone out, I can zoom in, and there's, sure enough, I can see the label. But by the time I zoom in on my computer, I can't really read anything. Whereas if I zoom in with an actual zoom lens, I can then look at that and I get all kinds of information. I get the model number, I can get things about the wattage, the voltage, the manufacturer's name, all of that stuff. So it doesn't hurt to actually have a zoom lens. Here's another case where I was on this was some canopy lights, and the client was pretty sure that they had 100 watt, maybe even 125 watt metal halide lights. And I zoomed in on the label, and I could see that actually it was 70 watts. So that might be make a big difference to the client, whether or not they actually want to move forward with that retrofit. Or at least it'll give them some forewarning that they may not get as much of a payback as they thought from their utility. At some point, the utility is going to need to know what is the wattage. And we could have horsed around and got ladders out or a lift, but just having a nice zoom lens saved a lot of effort. All right, so another thing is to look at the light distribution of the fixtures. You know, are they direct luminaires? A lot of times we think of a direct luminaire and we think here's a troffer, sort of a side view of a fluorescent troffer you might see in an office, and all the light comes down. That's a direct luminaire. Here's a high bay luminaire. That's a direct luminaire. We're looking at a recessed can. That's usually direct. Here's some decorative pendants, and they're direct. Here's a parking lot light. That's direct. So a direct luminaire can take different forms, but it doesn't hurt to know what they've got. Indirect luminaires, their light is dependent on bouncing off of adjacent surfaces to light the space. So here's a side view of a linear pendant. So all the light would bounce off the ceiling and have to come back in. Here's some wall mounted. So if we don't have a light colored ceiling there, we're not going to get a lot of light back. So we see occasionally people will have something like a direct luminaire and they want to change it to an indirect luminaire. And you need to have a conversation with them about how that's going to impact the lighting. It may be positive. Maybe that's a good way for them to go if they're having contrast problems or some other issues, which we could discuss more in a design class. But just bear in mind that if you change from one type to the next, you may have, it will impact the quality and even the quantity of the light. And so here we have a lot of fixtures are indirect and direct. Here's a linear side view of a linear pendant that's indirect and direct. And here's a high bay fixture with a prism. Now, these can fall into two categories. Sometimes it'll be indirect, direct, depending on, there'll be quite a bit of light that comes out. But if it's a high quality one and it's designed a certain way, you're actually getting most of your light down. So at any rate, have that conversation. Here's a case where we have a little cafe and maybe they have these fixtures and they want to get rid of them. They don't like the way they look, or someone showed them something else that they want to put in, and they want to go to this metal cylinder. So again, that may be perfect. It may put more light down on the tables. It may be just the way they want to go. There may be some other reason that they like it, but let them know that it's going to not light the ceiling. Their ceiling will be dark, which could be good. And it'll change how the space feels. So there's aesthetic reasons and functional reasons why you want to know about the distribution of the existing lights. Also, you want to look at the overall condition of the components. Are the sockets in good shape, whether they be fluorescent or a sort of a screw-in type. They may be, the sockets or the wiring to the sockets might be fried out. So part of the retrofit is going to have to be replacing or repairing those things. So the lens is all yellowed. Maybe they want to put in all new lamps of some kind, but the ballasts are starting to age out and they're going to have to replace those. And that's going to add cost and labor, and maybe it's time to just replace the fixtures altogether. And what are we seeing? Is there stuff on the fixtures? Is this just some rain leakage that came in at some point, a little bit of water? Is it rust and the fixtures are not sound anymore? Or is it some chemical that's been leaking from somewhere? So it doesn't hurt to know what those things are, because that could have implications about what you do with those fixtures. And you want to look at the ballast types. A big issue, not so much anymore, but it used to be that fluorescent, especially magnetic style fluorescent ballast would have PCBs in them, and that's considered a hazardous waste. And so if you have older ballasts, particularly from before 1997, you have to assume they have PCBs. And in fact, if they don't say specifically no PCBs, you have to assume that they have PCBs. And so they need to be handled as a hazardous waste product, and that can be, impact. Most modern fixtures, fluorescent fixtures, or even high intensity discharge fixtures are gonna have no PCB in them. And then you want to find out too the voltage, right? Do they have 277 volts on their system, or is it 120 or some other voltage? And you can't just open up one fixture and assume that you know what they have everywhere. So here's a room. We opened up. We were doing a little audit, just a superficial audit in this space. All these fixtures are the same. We opened one up and we saw, that's interesting. Here's a ballast that's 2 lamp normal ballast factor. Here's a 2 lamp low ballast factor. Here's the next fixture over. Here's a 3 lamp fixture normal ballast factor. Even though it was operating 2 lamps, it was a 3 lamp ballast. So these are going to give very different wattage and light output readings. So understanding what your baseline is important to figuring out, one, how much light you're going to need if they want to keep the light levels the same or increase them, and two, what your baseline wattage is. And then are you seeing 277? Are there battery backups here and there that you need to be aware of? And you want to see what kind of controls they're currently deploying. We still see places where they don't have really controls at all in spaces, particularly industrial sites, but even some institutions, and all the lighting is turned on at the breakers. And one, it's bad practice. It's not code currently, so if they're doing a retrofit where they're bringing up to code, they won't be able to continue that practice. Plus, it's not very safe. But then do they have manual dimmers? Is it just on-off switches? Do they have timers, time clocks, occupancy sensors, and photo cells? So you want to look at what sensors are in place, what condition they're in, that kind of thing. Sometimes controls can be really easy, especially when you talk about daylighting controls. It can be challenging, but here's a really easy lift. And in fact, this could almost be done with a timer. So here we have this walkway. All these lights are on right now. You could probably in this space just turn the lights off at 9 o'clock every day and not turn them on again until 7 o'clock. But you could easily just put a photo cell too. So yeah. Here's one that often gets overlooked, but I think can be fairly important. Document existing room surfaces. So why do we care about room surfaces? Well, they can mitigate brightness ratios, they can control contrast, and they can actually add to higher light levels. So let's take a look. So here's a little model that I did a little while back, and here we have a little 2-story building, and we have an upper floor and a lower floor, and the lower floor looks darker. Guess what? It actually is darker. It's the same lighting system, same power density, same everything, except the surfaces down here are darker. They kind of look the same. We still have yellow and kind of off-white walls. So what's the difference? Well, the difference can be rather significant in terms of actual measured light levels. So if you ever do lighting calculations, you have to tell computer modeling, you have to tell the space about, tell the computer model about the space. You have to define the size of the space, the volume, and then you have to tell reflectances. And if you don't know the reflectances, there's certain default reflectances. So we assume 70% for the ceiling, 50% for the walls, and 20% for the floor. And those are industry standards, and they usually it just defaults to that because that's often what you will find in many spaces. Well, let's say that your customer has very aggressive energy saving goals. They want to be a LEED building, and so you're really pushing on the tolerance of what your lighting system can do. So you run your model. You haven't talked to anybody else about what the reflectances are going to be, but you just assume. So you're at 35 foot candles. That's their target light level. But when you go out there for the big ribbon cutting, you turn on the lights, it's really dim in there. You're down, it's like there's a big difference between 35 and 23. Everyone's like, boy, this isn't really what we expected. That's because maybe the customer has a wood ceiling. Maybe they've got saturated colors on the walls, or maybe they have brick, and they've got stained concrete floor, or they've just got a dark carpeting. It could go the other way. Your client could have a high reflectance ceiling tile. They could have a bright surfaces on the walls and maybe a bamboo floor, as we see here. So here we have a light colored floor, we have light colored ceiling. You know, so this can either really help you or hurt you depending on which direction you go, and you need to have that conversation. If we look at this space here, this is a fairly common building vocabulary for surfaces. You see this a lot. So we have a dark stained floor. We've got saturated colors, dark wood, concrete. So that can happen to you. Or if they currently have that and they say, yeah, we want to be LEED platinum, you're going to tell them that's going to be difficult to achieve your lighting energy goals that way. You know, and this doesn't, we're not talking, this can be any kind of environment. Here's an industrial environments where having these light surfaces just really helps safety, brightness. So you can have a much lower power density just by changing some of these surfaces. Again, it doesn't have to be sexy, right? So again, and I understand that, you know, that may be a conversation they don't want to have. They don't want to have to paint that's extra cost, but it could save them money, and it could also make it a safer, more inviting environment. Even if it's, say, this was a hotel, you know, people coming into this parking garage or that parking garage, you know, which one seems better? So. If it's an existing building, maybe you want to find out what the current reflectances are. It's not that hard to do. You can take your handy little light meter and what you do is you take a light reading with your meter on the wall at a space that seems representative of the general light, you know, not in a bright spot or a dim spot, although it wouldn't actually matter that much as long as you do it consistently. So you take your light reading, and then you take your light meter and you hold it out from the wall about a foot and turn it towards the wall. So now it's seeing the light bouncing off. And then you do a simple calculation and that would tell you the difference. So if we had 80 foot candles incident shining on the wall and about 20 foot candles reflected off the wall, we're getting about 75% absorbed light. So, you know, we have a fairly dark surface. And so you could have that conversation. You could say, you know, if we painted these surfaces, this would make this a lot easier for you to save money or to get more brightness without spending more money on lighting energy. If it's new building or they're going to repaint, you can say, well, what are your paint chips? Because often they'll tell you, here's a 74% reflectance. This one is 50% reflectance. And so that's another way to determine that. So what's the best time to do an audit of your exterior lighting? Just shifting gears here a little bit. Well, you'd think at night, right? We want to know what the lighting's doing at night, and we got to go out there at night. And that's certainly true. But you can also learn a lot during the day. So if you go out during the day, you find out that these lights are on when they shouldn't be on. You go out there at night and they're just on. So you don't know that there's a control system that's failing. They're spending a lot of money here for no purpose. Another thing you can tell during the day is that this lens, so when you look at a fixture at night, it's just bright. You know, you're just looking at it, this glare. You can't really, you know, tell much of anything. But if you go out there during the day, you can see that this lens is yellowed or dirty or damaged or something, and that may help them increase their light levels, or at least it points out a problem. Another thing that you can tell during the day with systems is you can take your handy zoom lens and you look at this fixture, you take a picture and you zoom in, and you can see maybe they have some infrastructure issues. Maybe they have rust or deterioration in some way that they may want to address while they're doing a retrofit. Doesn't it make sense to put a lot of brand new fixtures on some poles or some standards that are going to be failing shortly? Some additional tools that you might bring if you're doing especially an advanced or a specialized audit would be a luminance meter. So most your regular light meter that you would have measures illuminance, that's the amount of light striking a surface. But if you've got, you want to know how much light is coming off of a surface or off of a light source, maybe they've got someone complaining about glare, or they've got some other issue, you use this tool to shine at the surface or at the light source, and it'll tell you the candelas that are coming off that. And then data loggers. It may be that you're doing a big warehouse or some other large facility, and they're like, oh yeah, we never use these areas, so we want to put lower light, or we're not sure what the usage is. You put data loggers in there and they'll tell you either when the lights are coming on and off. They can also tell other things, power usage, and a variety of things. Spectrometer is a big issue now. People want to know if there's UV light or if there's what the spectral power distribution is of the current lighting. Flicker is coming back, especially with the advent of LEDs. So that's a topic. Thermal imager, they might be having lots of premature failures on their lighting equipment, and you can say, well, gosh, yeah, these fixtures that are, sitting here over this big piece of equipment, maybe something is blowing a lot of hot air. This fixture is getting way overheated. UV meters, and then a GoPro. Sometimes people just wear a GoPro and they just have that running all the time as they're doing their audit. They can always go back and look at the light. So one question that always comes up early on in a conversation about lighting is how much light quantity. What is the quantity? And that's a kind of I don't want to say a moving target, but it's a changing target. I love this picture back from 1939, Nela Park. Here we have the captains of industry sitting around making decisions about something important, I'm sure. And they're excited about the fact that they're under 200-foot candles of diffuse light. And, that's a big number for interior lighting. And they were doing it because they could. It used to be that when all they had was incandescent lighting, you couldn't get a lot of light with incandescent light unless you just used a ton of energy. And here they're able to get really bright light with not much energy. So they're excited by that. We go to 1972. Here's the IES handbook, the Illuminating Engineering Society. And they have light level recommendations. And here they have for general offices, reading, different tasks, different visual tasks, handwriting, 150-foot candles, 100-foot candles, 70-foot candles. Even the low level is fairly high by today's standards. And again, they were doing it because they could, and no one was really, there weren't energy codes back then to speak of. We go to present day, the 10th edition, current IS handbook, and we see light levels for offices, reading and writing, and we see for pen, black ink, 300, we go to here, blue ink, 400, 300, 400, that's big numbers. These are lux. So we typically, in this country, we talk about foot candles. The rest of the world uses lux. It's like metric system. So that's the bad news. The good news is that it's easy to convert from lux to foot candles. 300-foot candles is about 30 foot. 300 lux is about 30-foot candles. So it's 10 to 1. If you're really wanting to get exact, it's not exactly 10 to 1. So you'd want to do a calculation, but for the most part, we're looking at 30 to 40-foot candles here, and that's certainly what we typically see in a lot of offices. 35 is often a target that we're using. Okay, related to the quantity is, what's the lumens per watt? How much light will I get? And it's a reasonable question, but we hear this as lighting professionals and we're like, well, how much will you get? It depends. And so let's look at this fixture. Say we're doing a high bay application of some kind. And I think, Armando, this might be the point where we're going to ask people about color rendering and color temperature.
Exactly right. Pulling that up, Eric. All right, so this is a nice, just wanted to poll the audience. How familiar are you guys with CRI and CCT? Whether you know a lot or a little, and that'll help Eric understand how much to go into the topic. So please vote. Let us know what level of engagement you like with this topic, as it will relate to audits and retrofits in the next following slides. A good amount of people started voting already, so thank you very much. Past halfway. A few more seconds. All right, Eric, so we got about half of the people know all about CRI and CCT, so we got a good amount of experts on those terms. You got 38% saying they could use a refresher, and about 30% would like to get a bit more knowledge on them, and about 8% wanted to make pizza in this class.
Yes, so do I. All right. Well, let's just run through it then. Thanks, Armando. And I'm wondering about getting to those slides. How do we do that? Do I have to unhide them or something? Any thoughts?
Thinking, what is the next slide after this?
Well, so we're on looking at the Luminaire options. And I was going to do a little run through on color rendering and color temperature before that.
It's possible. It's not here, so maybe you can do a quick breakdown and
Yeah.
go forth.
Yeah, no, that's great. All right, so here's the thing. Color temperature is what color the light appears to be, whether it's sort of bluish or yellowish or pinkish or neutral white. And the higher the color temperature, the bluer the light typically. So we'll see something that might be, say, 3,000 kelvins, and we use the Kelvin scale to talk about the color. 3,000 kelvins might be considered a warmer, yellow or pink light, and then we get up into, say, 4,000 to even 5,000 kelvins, and that's sort of bluish, whitish light. So that's CCT, correlated color temperature. Color rendering index, CRI, is how well the light source reveals this sort of true color of the object. How well does it render color? Some colors, some lights that we use architecturally are fairly poor at color rendering. And the reason we bring this up now is because they do have, that has an impact on the performance beyond just aesthetics of the light. So let's take a look at this. So here we have, let's just go back a second. Well, actually, we can work it from here. So here's this high bay fixture that we were looking at, and it comes in a range of lumen outputs, and the wattages would be higher as we go. So we can go in from 9,000 up to 30,000 lumens with this. We also get to pick color temperature. We can go 3,000 kelvins, 35, 4,000, and 5,000 kelvins. And then we get to pick color rendering, 70 CRI, which is good. It's a good color rendering, but it's not great. And then we can go up to 90 CRI. So the higher on the color rendering index, that's a scale I didn't mention that goes from 0 to 100, and normally the higher the better. Anything below 70 is considered somewhat mediocre. So 70 is pretty good. 80's better. 90's great. So you're thinking, well, why don't we just use 90 all the time? Well, let's take a look here. So here's our nominal 3000 lumen product. But if we look at the actual lumens, we're not getting that. We're getting at the highest. Here we have about 2,900 lumens here. Or 29,000 lumens, excuse me. And that's for a 4,000 Kelvin 70 CRI fixture. And that may be perfectly adequate for, say, a warehouse, a gymnasium, maybe, but actually probably not. Let's say warehouse or some sort of maybe maintenance yard where you're doing work on trucks or something like that, or industrial facility perhaps. And we go all the way over to here where we have 19,000 lumens, 19,700, almost 20,000 lumens. So that's significant difference. We go from almost 30,000 down to 20,000 lumens for the same fixture type. Here it's 3,000 kelvins, 90 CRI. Well, maybe I'm putting these lights in a food court at a college, or maybe that's an airport concourse or something like that, where I want a nice, bright, high CRI light that, or maybe it's some sort of high lobby in a maybe industrial facility, and I want it to the high color rendering there. It's important. Or it's a big box retail store, Target or something. Well, the difference between the 4,000 Kelvin 70 CRI and the 3,000 Kelvin 90 CRI, I go from 125 lumens per watt down to 80 lumens per watt. Don't get me wrong, 80 lumens per watt is still good. And if I'm doing a Target or a food court, I have to have 90 CRI, but I do pay a price dollar-wise and also in terms of energy consumption to achieve that goal. Just like down here, I get much higher lumens per watt. Well, maybe if I'm doing a LEED building or a net zero building, maybe I have that discussion that we have slightly less quality light because we know it'll help us achieve our aggressive energy goals. So it's not sort of one size fits all. You can't just interchange these. There are implications in terms of costs, quality, and light output that are solely dependent on color temperature and color rendering. And so bear that in mind as you're making choices. And it may be that you use the same fixture on a big campus or a big facility. It's just that you know that in the maintenance yards you're using one thing, the storage facilities are using another, the lobbies are using something else, the gymnasium it's another one, and the food court it's something different. So you might have 4 fixtures. They all look just like this, but they all perform very differently. Okay, I think we beat that to death. That fixture though comes in all these different ways depending on the color temperature, the color rendering, whether it has a lens on the bottom, all kinds of things. So when people say, well, how much light will I get from that fixture? You have to say, well, I need to ask some more questions and do some analysis. Okay, pop quiz.
Very nice. Coming right up. All right, everybody, what are the benefits of light interior surfaces? Multiple answers you can select, so please select all that apply. All right. Again, asking everybody participate in the polls as much as we can. Yep, I see a good amount of people voting just now, past halfway. Thank you guys for engaging. I'm gonna leave it in for a few last seconds. All right, so what are the benefits of lighting interior surfaces? Hey, the majority, 93%, potential to save energy, 86% improve visual comfort, 64% lower contrast ratios, and another 86% potential higher light levels. So pretty solid on those choices. Not isn't just interior design.
Okay, nobody fell for that one?
Nobody.
All right, excellent. You all get an A for the day. Right, so check your surfaces. All right, thanks, Armando. And I should say, I'm assuming nobody has any questions. If you do, please put them in the chat, and we can address them at any time.
Nice.
All right, so we're going to take a look at some common retrofit application types: recessed cans, exterior, industrial, fluorescent, 4-foot fluorescent fixtures in particular, and then maybe some decorative fixtures like you might see in hospitality applications, hotels, apartment buildings, etc. So one area that's of a lot of interest for people are so-called TLEDs, LED tubes. Since the LED revolution, you know, the 4-foot fluorescent tube by far is the most pervasive light source in the marketplace, particularly obviously for commercial and industrial applications. So we see a ton of these tubes. So it seems to be a target-rich area to do retrofits. And you know, there's a lot of these tubes out on the market, and they use LEDs, and there's a variety of form factors. Sometimes we'll see them with no diffuser, so you just see the raw LEDs. Sometimes we see wide ends, or sometimes they're very narrow ends. Less so now, but we still occasionally see metal heat sinking. And then lately we've been seeing glass. Most of these tubes are plastic, but we see a lot of them with glass. And the reason we see glass is because glass is cheaper. But it also takes away one of the nice advantages of the tubes, which is that they are less fragile. They don't break. So that's, you know, now we have glass, we're back to the old fluorescent breaking tubes. All right. So another thing that we see with these tubes is the distribution is different. A regular fluorescent tube, here's our cross section of a fluorescent tube, the light comes out more or less uniformly all around it if we measure it carefully. Especially in the early days, we were seeing these tubes, especially where they would have metal on the back. Well, you can't get any light out the back, but even worse, especially with the ones with no diffuser, the light comes out in a fairly narrow pattern out just one side. Even some of the wider ones were getting a little bit wider, maybe a little wider still, but not actually omnidirectional. Why do we care? Well, in some cases, it actually might not hurt us. It might help the situation to have that directionality. If it's a recessed fixture and we're trying to push light out in one direction, we don't really care if it goes up the back. Now, bear in mind, it can affect the appearance of the fixture, even with a lens on it. we see some patterning that's different just because it's not omnidirectional. But that may be not a big problem. But it is a big problem if we have an indirect direct fixture where we have to have some light coming out the top. Here's our light source in the middle. So it has light out the top, light out the bottom. Well, if we have a fixture, a light source that only gives light one direction, we have to choose which it is. And that's, going to be a compromise at some point. And then we get into wiring on these things. How are they actually installed? So there's three types, so-called no rewiring ballast compatible BCT LEDs. Ballast compatible meaning on a good day, you just open up your fixture, take out the fluorescent tubes, pop in the LED retrofit, close the lid, turn it on, and you're done. That would be the perfect scenario, which would probably never happen. Another scenario is where the reason being that this ballast compatibility. So in the earlier types of TLEDs, you would have to rewire. So you'd have to bypass the ballast. And at that point, you don't have to worry about compatibility, but now you're wiring and putting direct energy. Hang on a second. To the sockets. You're putting line voltage at the tombstones. And one thing about those is they were never really designed to have line voltage there. So there's potential safety issues. Plus the way these get rewired varies from manufacturer to manufacturer. And then there's rewiring where you have a remote driver. I haven't really touched on this yet, but LEDs, instead of a ballast, they have a driver, which is basically their power supply. And in most fixtures, the driver looks like the ballast, and it sort of sits in the fixture in roughly the same place. But with a lot of these TLEDs, whether it be ballast compatible or the rewire, everything is inside the LED tube, except in the case of these where you have a remote driver. That'd be separate, and we'll look at that. And so UL is considered Underwriter's Laboratory of UL type A, UL type B, and UL type C. This is important, especially if you are wanting to get a utility rebate, whether or not your fixture is deemed, whether or not your measure that this product is deemed to be a tube or a kit. And we'll see as we go that that's not quite as easy to determine, but it may have a big impact on what kind of rebate you get going forward. All right, so ballast compatible TLED, read the fine print. So this says it's compatible with 90% of electronic T8 ballasts. Okay, hopefully we don't have that 10%. But there is a little asterisk, and it says down here, due to numerous ballast designs and topologies, this lamp should be tested on existing ballast before mass quantities are installed. Okay, and then it says not intended for use with older dedicated voltage instant start ballasts. Well, usually if you're doing a retrofit, you have older product. These ballasts may degrade over time. Well, all right, and it doesn't make sense to put in a bunch of brand new TLEDs in a fixture with a ballast that's going to fail in 3 years. But still, you might remember that picture I showed you earlier about the building we went into, and we started opening up the fixtures, and we saw a whole range of different ballast types by different manufacturers. So you can imagine in a big facility that's 40 years old, there's been retrofits over the years, or there's been maintenance done over the years, and you're going to have a whole range of ballasts out there. Here's the rewire TLEDs. Eliminates the concern about ballast compatibility. That's good, but so must include an integral driver. Improper wiring can result in product failure. Further, each lamp type may require shunted or unshunted lamp holders, shunted or unshunted sockets. So you got to look at those sockets that are on your fixture. And so here we have further from the same manufacturer. So it says here, rewiring and the sockets. So what are they talking about? Well, so it says right here in the fine print, do not use this retrofit kit in luminaires employing shunted bipin lamp holders. Okay. And this says shunted bipin lamp holders are found only with instant start ballasts. Well, I'm just going to say that by far the most common ballast you'll find on the marketplace today is instant start in existing buildings. So, you know, you need to think that beyond just using the tube, you're going to have to replace the sockets in the fixture. So it's it's some electrical work and cost. So remote driver tubes still using the sockets. So sometimes what we'll have is this is the UL type C, where we have a driver and the tubes are included. So lamp requires dedicated external driver, and you may have to change the sockets, but they give you all of that, the sockets and the driver and the tubes as one happy family there. So that may be helpful. One of the things that UL talks about is they deem anything that gets energized by the tombstones, by the sockets, to be a tube. Okay, I believe that Design Lights Consortium, who's another player in this in terms of deeming what things are, they call those, this would be called a kit by the DLC because it's got a remote driver, but it's still getting energy from the sockets. Here's one that we see occasionally. So here's one where we have a remote driver and we have power coming into the tube separately, not from the sockets. So the tombstones or the sockets are simply there to mechanically hold the thing in place. So it's not getting energy from the sockets, but you might run into trouble with UL because they're going to say, well, it's touching the sockets, even though the sockets aren't energized. So it's a bit of a mess. And the other thing you got to be aware of is that older fixtures, those sockets they degrade over time. They lose their spring action. Sometimes the plastic gets broken from heat. So you may need to replace those sockets anyway, because they're not physically going to hold these in place very well, especially if it weighs a little bit more than the fluorescent lamp you took out. So here's probably the most basic kit you could find. It's one that has these little things that look like tubes, but they don't touch the sockets. They just stick up there with magnets. And then here's your power supply, your driver, that's remote. So this is a kit. Now, bear in mind, this doesn't change your optics. And when these are working as best they can, they look just like the tubes that you took out. So if your client wasn't happy with the lighting before, they're not going to be happy with this solution either. They might save energy, but they won't get different lighting at all. Then we have other kits that are more complete kit that have new optics, right? So here we've got a new lens. So now we have a new look. It almost looks like a new fixture. Bear in mind, some of these kits have lots of parts and pieces that you have to assemble in place. And you know that can take a little bit of a learning curve. Plus, it can be things you're dropping or losing, or otherwise can be a little more work. Sometimes, though, that everything's there, and you just take out everything that's in the existing fixture, wire this thing in place, close the door, and it's like a new fixture. And they often cost as much as a new fixture. And the reason you might use that is because you don't maybe want to go up into the plenum, you don't want to take down those old fixtures because there's asbestos or it's very dirty, or you just material you don't want to throw out, all those big steel housings. So there's just different ways to go once you get into the kit range. But bear in mind, if you've got a facility and they're doing a major remodel, new tenant or new carpeting, new furniture, new paint, everything, and the same old fixtures, even if they are LED, you know, maybe they want new fixtures, new lighting too. So that's an opportunity. All right. So one thing that we see, especially with decorative fixtures, is it's a little hard to determine what your light levels are going to be. And you can't just look at lumens, which is often the only information you have, short of careful photometric analysis. So here we have a fluorescent. Here's our existing fixture, decorative. Maybe you've got a hotel, you've got hundreds of these, thousands running down the corridors, and they use 4 18-watt, 1800 lumen compact fluorescents. So we got 7,200 cumulative lumens. Well, we look at this LED fixture, 24 watt, a lot of energy savings, but it's only 2,500 lumens. And here's another one, a little even more energy savings. It's barely 2,000 lumens, not even. So you think neither of these are going to work. But let's look at it a little more closely. So let's take this fixture, we'll look at its photometric file. Well, it turns out this fixture is 37% efficient. That means less than 60% of the light makes it out of the fixture. More than 60% of the light is wasted in the fixture. So if we do a calculate on that, we're actually getting about 2,600 Luminaire lumens. All right. So now we look at the LED fixture, and we were getting 2,500 lumens. So that doesn't look so bad. It looks like it's almost an equivalent. But if we look closer at their spec, it says source lumens. What that means is they didn't actually do a photometric on that. They just said, okay, we're going to buy Acme LEDs and put them in our fixture. And when these Acme LEDs, the company that sells them, they say these LEDs, this little LED array puts out 2,500 lumens, 2,500, 500, or 2,558 lumens. And we're going to pop them in our fixture, but we don't know what's going to happen after that. Well, if it's anything like this fixture, we're going to lose a lot of those lumens. They're never going to make it out. We know that. So we don't know how many lumens we're going to get. Let's look at this one though. This one had the 1800, almost 1900 lumens. Then it says delivered lumens. That means that's how many lumens actually make it out of the fixture. So we get about 2,000. So that's a lot closer to our target that we had with our original fixture. So that's a big difference. And so what we're looking at here is when we look at our specs, we can look at Luminaire lumens or something else. And really only Luminaire lumens tell you where you are. And if you change anything, if we tried to change the lens type, or if we change the finishes or anything else, we have to send it back to the lab and do more photometrics so we know what the lumens are. This is also true to some degree with screw-in type lamps. So here we can have a directional lamp that is 75 lumens per watt, and here's a omnidirectional that's 95 lumens per watt. But what we care about is how much light's delivered to a surface. And we'll probably, if we're accent lighting artwork or shining light on store displays, we're going to get a lot more light delivered with a directional than we will with an omnidirectional. So you can't just look at the lumens or even the lumens per watt. We look at a thing called the beam angle and the center beam candle power. So here's our directional light. And we see that we have the amount of light that comes straight out of our little spotlight. And then when the light level falls off by 50%, that's the beam angle. And we'll often see that listed in the specifications. So something with maybe a 40-degree beam angle or 15-degree beam angle, those are going to give us different amounts of light, different intensities at whatever we're shining them at. So here's 3 omnidirectional light sources: a compact fluorescent, in this case a metal halide, and an incandescent. And we see them put into recessed cans. Here's our little recessed can. And we have the same experience we had with that decorative fixture. So here's our omnidirectional light source. It's 65 lumens per watt. But when we put it into a recessed can, it's only about 50% efficient. We lose 50% of the light. So we're at about 35 lumens per watt. And that's why we can take, well, if we look here, a lot of that light gets wasted out cooling vents. So if we look up in the plenum of this recessed can here, we see a lot of light. We shouldn't see any light up here, but we see a ton. We can read the label quite easily without any other additional lighting. That's because that's all wasted light going up into the plenum. And that's why we can take out say a 26 watt compact fluorescent and put in a 13 watt, or in this case 14.5 watt LED directional, and get the same amount of lumens because we're shining it out. We're going from omnidirectional to directional. But so we see a lot of these LED retrofits. So here we have pin-based LED compact fluorescent and pin-based LED retrofits. But you need to be careful with those as well. Just like we had with the tubular LEDs, we still have problems with the compact fluorescence LED retrofits. So here's one that says LED replacement. Simply plug the replacement into the existing ballast. What could be simpler, you'd think? Well, we need to check compatibility. And so I did a little testing on some at the lab. And so we looked at, in fact, this was the ballast that was in a compact fluorescent fixture, the Advanced SmartMate. And sure enough, I look it up here and I see that it's compatible. It's only not compatible if I have 2-lamp 277 volt, but I don't have that. I have 120 volt 2-lamp. So it should work, but it didn't work. So I'm like, wonder why. I started looking at some of the fine print, and it says while each ballast type listed has undergone testing, some have undergone revisions that may change operating parameters. So over time, the manufacturer changes components here and there. And so if you've got an older ballast, which you would on existing older buildings, it may not actually be the same components as the retrofit, and that's why mine didn't work. So performance on an on-site test before installation is recommended. Okay, good to know. Here's another one. The features, compatible with most fluorescent ballasts. Well, that's good to know. Except if we look at that little asterisk, we go down and look at the fine print, we see for maintenance and energy savings reasons, ESL Vision, that's the company, recommends bypassing all ballasts for permanent operation. Well, how many times have you done a retrofit on a building that was temporary? So usually it's permanent. And so they're recommending, even though they say it's compatible, they recommend you actually bypass the ballast. And that's a lot of work in a little recessed can to save 12 watts or something. So one thing that we're seeing a lot of are these kinds of kits. Here's one. So we're not going to bother sort of retrofitting. We're just going to kind of gut out everything and hook this up, and now we've gone from compact fluorescent to LED. One thing though that you have to understand is we've changed, so that's pretty good. And in fact, these may be fine for many applications, but bear in mind that we've changed the optics a little bit. So this light source on this example and on the one I've got here, now the light sources are like right there. It's not actually recessed, and that might be fine, but it might also not be fine. So you need to maybe check with just have the conversation, or even check it on a back hallway. If you've got floor after floor of these things, buy a couple, try them on some area, and see if it in fact is going to work. There are, that's an easy sort of entry level type of product. There are products if you're really wanting to keep the optics to get good performance that you can buy. That is more of a commercial, it's more high dollar, but ultimately will give you performance like you had before, with the probably better performance than you might have had with your incumbent. All right, so here we have HID, high intensity discharge. Only 2% of the sockets in the US market are HID, but they represent 26% of energy use. The reason being that these are often 400 watt or 1,000 watt. There's not very many of them, but they use a lot of energy. So it is, again, another area that is very ripe for energy savings potential. But one thing that you have to understand is high intensity discharge, particularly metal halide, is a point source. And it's just a little bright thing. And so I can build reflectors around that and get very good optics. I get good glare control if it's done right. I can shine the light far distance and still get good optical performance. With LED type product, if you want more light, you have to make it physically bigger. So here we have a little compact fluorescent. It's 760 lumens. If I want 10 times that much light, like I've got, say, in my parking lot, if I need more closer to 8,000 lumens, I need to make it bigger, and I need more LED chips, and so the optics are going to kind of go sideways. So there's a variety of types of products for HID retrofit to screw in that we're seeing on the market. And sometimes they try to have, if it's horizontal, they have light coming out just one side, or if it's more like a little spotlight, or if it's omnidirectional, this try to be sort of omnidirectional. None of them work that great in my experience. One thing that you need to be aware of, if you do find one that you think could work, is what's your reflector like? If it's a translucent reflector or solid reflector. We're seeing, especially if you go with a slightly directional one, you may have patterning that won't work. I know Costco is very concerned about the appearance of their high bay fixtures. They like that sparkle. They want it, and so this would not work for their purpose. Here's a case where somebody might recognize this as the bus tunnel in downtown Seattle. And so here's a case where they retrofitted, they had some big decorative fixtures, and they put retrofits in those, and that worked out fairly well. But then they had some smaller surface mount types where they just use a directional light as opposed to omnidirectional. And you can see that this upper part is dark, it's not light. And so as a result, if you look in this higher area where they have the big directional ones, it's all brightly lit. Here it's dark, all dark. That, probably isn't a deal breaker, but it's different, and it might have been a deal breaker depending on who the client was and how picky they were. So we'll just, wrapping this portion up, we're going to look at a little retrofit project that the Lighting Design Lab was contacted about. Here is a big industrial space. Here's a piece of racking. There's a little person. So it's a pretty tall space, a pretty large volume. And they had been approached to do a retrofit. They'd found a retrofit solution they thought they liked, and they wanted to know what we thought of it. And so we did a little bit of a baseline. They had mercury vapor fixtures, so almost anything would be an improvement. And so we did a baseline to find out they were getting about maybe 30-foot candles if everything was sort of new. Their lighting power density was about 2 watts per square foot. There were 64 fixtures that they were looking at. And so the retrofit proposal was one of these LED screw-in high bay types. And so they were looking at slightly more light, 35-foot candles, maybe, 0.7 watts per square foot. So they cut the power in more than half. So why not just pop the champagne corks and declare victory? But we looked at it and thought maybe they could do better. One thing to keep in mind with this, even though it has a screw-in base, you actually have to go up to the fixture and rewire the fixture. You have to bypass the existing ballast. So this is designed to operate off of line voltage. So they were going to need to send somebody way up there, a technician or a journeyman, to go and rewire those fixtures. This isn't just something you can screw in. And by the way, at that time, these were over $300. It wasn't just like a $49, let's see if it works kind of thing. So they were committing real money, and they would have put in real effort to installing these. So then we looked at, said, well, what happens if you just put in a real fixture? Just take down the existing ones and put up new ones. So here we had a fixture by CRI. Wow, we were getting 80 lumen, 80-foot candles rather, a lot more light. It was still a lot of energy savings, but way too much light. So we thought, well, maybe they don't need all these fixtures. There's a lot of them in this space anyway, and they're fairly densely packed. So maybe we could get rid of some of them. So this is what it looks like. Here's our baseline. Here's the proposal that they originally had. And here's what we did if we put in, instead of 64 fixtures, we put in 34 fixtures. We're down at half a watt per square foot. We're at 42-foot candles, still kind of a lot. They might put in, they could have modified, played with it a little bit to even get deeper savings. Sure, these fixtures cost maybe $500 or so compared to the $300 screw-in. But guess what? We only bought half of them. We didn't buy as many. We had to buy 60 of these. Here we're buying 30 of these. So, you're looking at lower cost, initial costs, not to mention all the savings moving forward. Plus, you get the reliability of a new fixture with new warranties. Anyway, so it doesn't hurt to look a little further. All right, I think we got another quiz, Armando.
Sorry, I was stuck on mute, but yeah, you are very correct here. And I believe we are going with, before doing a lamp-only retrofit, always check to see which of the following, and you can select all that apply. So as before, you guys have been doing amazing. Please continue to vote in these polls. Asking that we please engage. Thank you for people that have been voting. Very good, very good. About 5-10 more seconds. Thanks a lot for jumping in. I'm gonna close it in 3, 2, 1, and we're gonna share. All right, so everybody selected the second choice, that the lamp is compatible with the fixture components. Very wise. 83%, the fixture is in good shape. 75% to the optics are appropriate. 42%, hey, the utility is agreeable for this project. And a 33% that the customer has enough money. That is smart.
All right, Armando, I'll kind of go through these.
Sounds good.
I still seem to be frozen, but I'll, all right, so yeah, you want to check to see that the fixture's in good shape. Obviously, you don't want to retrofit a fixture that's falling apart. Optics compatible and electronics, yes. You know, you want to check with your utility, because we see people that get pretty far down the road on a retrofit strategy, and it turns out that their fixture they're selecting isn't really going to be eligible for a utility rebate. So, you know, and the last one's sort of a joke, but actually, you know, that might be the first one to check too. Anyway, they're all applicable on some level. All right, so let's shift gears a little bit and talk about luminaire level lighting controls. You know, why do we use controls at all? Well, I mean, obviously to save energy costs and to save on maintenance. You know, we don't want to just leave the lights on all the time. But on some level, you know, we can have either all the lights on or all the lights off, and that's some level of control. But it sort of feels like a fairly blunt instrument, especially in this modern age, where people have different maybe work schedules, or they have different expectations. You know, so we're thinking occupancy sensors we use, but you know, here's a case where, okay, I mean, I don't want to diminish this guy, but you know, we have one person in a big room. Do we need all the lights on? Just like, you know, we could have a case where someone's working late. Well, they have enough light to work with, but you know, this may not be really a good professional practice anymore to have a building all dark like this, either for how the person feels or even just from a liability standpoint. So in this, as I say, in this modern age, we're used to having the intensity change, right? It's not just on or off, but we maybe want something in between. Occupancy levels, daylight. So as the exterior lighting changes, maybe the interior lighting changes too in response. And then preference. Some people maybe want more light, some people want less. And then sometimes the tasks change either over time or from hour to hour, and different light levels are wanted. So what kinds of controls do we use? Well, on-off switches are certainly viable in some cases, but we're looking at automatic controls for the most part, and those could be fixture-based sensors, ceiling mount sensors, wall-mounted sensors, more sophisticated time clocks at the panel, and then dimming, manual dimming, and wall-based wall box devices. You know, one of the problems that we had with the older sensors was they were very difficult to program. And people were put off by all these little dip switches or little dials they had to figure out. Now we have a nice clean look. This is a simple, so simple, just one button. The problem is you have one button to do everything. And so you're having to press this little button 10 times or 9 times to get some light level you want, or some delay time. And then you have to look at little blinks back, and you're trying to count the number of blinks. And then if you want to change modes, you have to do some other thing. And then you have to start counting maybe 7 different blinks or pushing it 7 times. You can imagine if you've got a big, like a school, you're going into classroom after classroom at punch list, and there's painters there, and there's, other people coming and going, and it's just a busy place. And this is kind of a recipe for disaster. So now we're seeing things that are more plug and play, self-programming. In theory, this is sort of a one-button setup. I've seen this product work, and if what you want is out of the box, you pretty much, if everything goes right, it is pretty simple. You just press that one button. If you want to change some of the settings, or there's something that doesn't go quite right, it can be a little tricky. But we are getting more towards this thing of self-programming. One thing that most people are used to now is a GUI, a graphical user interface, where you can, it's more intuitive. You can see what you're setting, and these systems can cost quite a bit, especially if you're having to buy touchpads like this for every space. But if what you're doing is maybe even using your own company phone that you already have anyway as your interface, that cuts out on a lot of those costs. Another reason we do controls is because we're required to do controls based on more aggressive energy codes. And so we're looking at daylight controls. And if we look at this floor plate here, we see a lot of perimeter. And so we know about daylight zones, but now we're required to do primary and secondary daylight zones. It's not good enough just to have a daylight zone. You've got to, it's a little more nuanced. Another thing we're required to do is occupancy. All right, and so we're like, well, yeah, we do occupancy in small, enclosed offices, break rooms, conference rooms, different little interior spaces. But guess what? Now we need to do occupancy in almost everywhere, common areas, multi-use, open office type spaces. And then we have egress lighting that we may be part of that control strategy. So once you add all that together, it makes for a pretty crowded zoning. So, empty room, lights on, not good. The room's empty, lights are off, that's good. But what happens when someone walks into that space? We don't know looking at this. What we see as success is you have a big space, lots of daylight, the lights are off, people are inside. That's a good thing. So controls are mandatory, but a big exception, although it's not a real exception, is if you're doing Luminaire level lighting control, LLLC. And that's defined as a lighting system consisting of one or more luminaires with embedded lighting control logic, occupancy, and ambient sensors, wireless network capabilities, and local override switching capability. So each fixture has its own controls. That could never happen. But guess what? We're used to putting controls on individual fixtures, so it's not like it's never been done before. And in fact, we're starting to put them in warehouse spaces where we have, we couldn't do that in the past with the old high intensity discharge. Now we can do it with LED or even fluorescent. But in a warehouse, you've got relatively few high wattage fixtures. There's a lot of savings there. You go into an office and you've got lots of fixtures and they're not as high a wattage. So putting controls on each fixture there might be some like head scratching there. But guess what? We are at the convergence of technologies. We've got miniaturized controls. They're tinier. By the way, that's not the price, that's the size. We have controllable light sources. So instead of high intensity discharge, which is basically non-controllable, or fluorescent, which was hard to control, we now have LED. We have higher bandwidth, so we can handle all the data that might be coming from the with a high density control system. And we also have more demanding energy codes, so there's an incentive, if you will, to do these controls. And the advantages are basically, we can track lots of kinds of things. We can control for lots of things. We have higher granularity, as we'll see in a moment. You often don't need to rewire because all you do is hook the fixture up and the controls are already there. And we can rezone easily if the use patterns change. Why are we putting all this in the lighting? Because it's a handy place. Lighting is kind of everywhere that people are. It's above us, so it has a good view of the space and what's going on in that space. And guess what? Most lighting has electricity running to it. So it's already got some power. So let's take a look at this floor plan here. Here's a little office, big office, and take a look at what might happen. So let's say it's nighttime and we've got just the egress patterns. We don't want it to go completely dark, but we've got the egress path down to a minimum. It's down at 10%, just a little glow. So who knows why? If someone was trapped there, they could find the elevator, and if the sensors didn't go off for some reason, or the stairs. But let's say we get somebody that arrives early. It's still before dawn. And so they come out of the elevator and these lights pop up to 90%, and they go out into the corridor and these go up to 90%, and the whole floor plate says, oh, somebody's in the building or in the floor. Let's go up to 30%. So all these lights come up. So it's not dark, it's just dim. But where this person is bright. And in fact, they go to their desk and this is up to 90%. So that's how that might go. Let's say a coworker arrives a little later in the day, in the morning. Now it's dawn, and so we've got daylight coming in. So now our 30% zone is constricted. This is all more or less off because it's in the daylight zone. Our worker is still working here. He's in his 90%, and the new person comes in and they get 90% and 90%. Where they're working. And then as the day progresses, other people arrive, the day's still there. So we, and maybe some spaces have the blinds shut so they don't have daylight. So the light's up to 90% because it's occupied. And that's how that might go. Very granular, as we say, especially late in summer where maybe it's lightly occupied and we don't have everybody in all the cubicles. I love this picture. It doesn't have to be troppers, so-called. We can have this on pendants. So here we have this light is on here. This person's sitting there at their desk. But guess what? This light's off. Nobody's there. This light's on. The person's sitting there. Here we're in the daylight zone, so the ambient light is off, and maybe the task light looks like it's down at a low level. So that's how that might go in another situation. So I think we have the last of the pop quizzes, and I think I'll read.
We are launching. Oh, say that again, Eric.
Well, no, go ahead. I was thinking I might read through this one. I think maybe
sure, go ahead.
Yeah, I think we decided that we didn't have enough choices or something, but
sure.
Here we have the most effective retrofit luminaire. A is energy efficient. B has appropriate color qualities. We talked about that earlier. C puts light where it's needed. So we talked about distribution. Has low operating costs and is controllable. And of course, is all of the above. So you should be looking to do these things in every application if possible, and the priorities may vary depending on the particular case. So we just wanted to give a little love to some of our local utilities. So if you're doing a retrofit, they always say call us first, and we hear that a lot because often a customer, as I mentioned earlier, might go down the road to do a retrofit and they haven't contacted the utility. And then it turns out that they have to change something or maybe get a different fixture or, do something that they should have, some other paperwork. So call these numbers. Here's Seattle City Light. There's their energy advisor number. Puget Sound Energy. Here's their 800 number for their energy advisor hotline. We've got Snohomish County PUD customer service or toll free. You can call those if you're thinking about doing a retrofit. And then last but not least, Tacoma Power, Tacoma Public Utilities. And there's their various phone numbers depending on what's the nature of the project. So, or you can go to our website, especially if maybe you're in Idaho or you're somewhere else in the Northwest, BC Hydro. You can go to our website and click on these, and it'll take you to those utility homepages. And I think that is it. If anybody has any questions, I assume, Armando, if you saw something coming through on the chat, you would let me know. But that's it for my portion. And I think we're just about on time.
No, very good. No questions. Just a couple people saying, "Hey, props on using props."
Okay.
But yeah, no, there's a few outro slides, Eric. Amazing stuff. If you want to transition to the outro slides.
There we go. Yes. Can you see it?
No, I cannot actually, but it
That's
may
all right.
just be a little bit of a lag moment.
Well, let me, I can read it. Upcoming LDL online events. So we got some courses coming up. We've got Intro to Codes and Standards. That's coming up August 25th, that same time. Promoting energy efficient lighting systems, September 8th, same 10 to noon. And then a What Went Wrong class, 10:30 to noon on September 22nd. So hope to see you all for that. And we will be sending out announcements on those as well, so stay tuned. Today's slide deck and previous online courses can be found on our website. I've reviewed some of those, and they're pretty good. Armando, are you back online?
Oh, I am caught up. Yeah, if you want to go to the next slide, I can finish it up. Again, you see Eric Strandberg's contact information on the screen. Any questions or comments you may want to take offline, please reach out or reach out to the General Lighting Design Lab at seattle.gov email. And again, today's class handout will be available on our resources tab, and a recording of this video will be available on our YouTube channel. I think we're going to the last slide. Before the last slide, I just wanted to again thank City Light, some of our member utilities, for supporting our programming and all we do. And that is all, folks. Again, thank you for joining us for another webinar. We'll have another one in 2 weeks. So stay tuned and stay plugged in. Thank you, everybody.
Thanks a lot. Bye.